The next topic is the method of disks. Here you will be given a function, say like this, the limit a to b, and this is the function. Now you will be asked to rotate this, then you will form a disk. Now what does it mean rotating is this function will be rotated along this x-axis. Okay, we will have to rotate it along y-axis as well, but now let us only focus on the x-axis. This is the axis. This function will be rotated like this. It will look like this. Now you can see when it goes down and it turns up, you will get this shape. This is having circular cross sections. Now you can see the same function a to b, but when you rotate it, you get like this. It is made up of many circular cross sections, right? So what you can do is you can find the volume very simply by using this formula. The limit is required until where you need to find the volume. From this point to this point, that is a to b, pi, f of x, that is the function square. You need to square the function. It's pi r square. Now, if you look closely, look at this. This is the function. So what is this? This is basically this line. So what is this line? That is the radius, isn't it? So that's why radius square or the function square, in simple terms, whatever the function is given. Why? Because you're rotating it along the x-axis. So that function at that particular point will be rotated. That will be the radius times dx. If you integrate this, you'll get the answer. Same way, you can try even rotating around the y-axis. Now over here, when you're rotating this function along y-axis, what happens? You will get this. It's again circular, but now we are doing along y-axis. So let us see. This is a circular cross section. Over here again, this limits in the y-axis limits c to d pi. Now this is the radius, the function gy square dy. With respect to y, we will see a problem you'll understand much better now. Rotation about the x-axis. Now, okay, this is just a quick review of the formulas to see. See, when you're rotating along the x-axis, it's something like this. This will be given function. Rotated, you'll get this. This is the formula. For y-axis, this is the formula. Now, we will see an example problem. Revolve the region under the curve y equals square root x on the interval 0 to 4 about the x-axis and find the volume of the resulting solid of revolution. Now, basic thing, we have done this since the last lesson. So please remember it is continuation of the previous lessons and the previous video. So if you have not watched the previous lesson, please watch it and then continue over here. We had learned how to graph in the previous lesson. So with basic knowledge, let's graph it. Now, you know this is a square root function. Square root function starts from 0 over here and it just goes like this. Now, over here, the radius is basically this function, square root x. Okay. Now, when you rotate it, it'll be something like this. So you can see. What do we do? Substitute the values in the formula. That's it. It's very simple. But what is the limit? It's given 0 to 4. So a is 0, the smaller value. B is 4, the bigger value. Pi is constant in the formula. F of x means the function, that is root x, the whole square dx. Now, you can solve it using formula or you can just use the calculator. You can use this symbol, pi, shift and this symbol over here. You'll get pi, multiply it with, you can use the brackets because you're squaring. It is square root alpha x. Close the brackets and square it up over here. It's from 0 to 4 and you'll get the answer 8 pi. So that is the answer, or you can even just press this and get the units. So square, it is, okay, there is an error over here. I'm sorry, I apologize. It is unit cube. Volume is always to the power 3 because there are 3 dimensions. Please note, area is unit square, volume is unit cube. I will make this change in a while. I'm sorry for this, but please remember. So we will do the next problem as well. Find the volume of the solid resulting from revolving the region bounded by the curves y equals 4 minus x squared and y is equal to 1 from x is equal to 0 to x is equal to root 3 about y-axis. So now if we see this, it's what a parabola, negative parabola. So it'll be like this. But this 4 denotes it is having the y-intercept at 4. So if it's like this is 4. Okay. And the line y, 1, sorry, y is equal to 1. So this is being revolved. Let me show over here. So this is the part. Now this is being revolved, isn't it? So now over here they have taken limits of 0 to root 3. So one second, I'll just show. I've drawn the entire figure. This is the parabola when it is 4 minus x square and y is equal to 1. But what are the limits of this graph? It's not the entire limits. Now whatever I have drawn is in the negative side. No, you have to take from 0, and this part over here which touches is root 3. Okay, it will be 1.7 something. It's less than 2. Now this is the value 0 to root 3. Only this part of the graph is considered. So when we have such case, it is very hard if you do it along x-axis. Why? There is a gap over here. It's hard. So now in such cases, it's very easy to use y-axis revolution, and it's also mentioned over here, do y-axis, but otherwise you must understand it's easier if you do y-axis. So y-axis revolution would mean it'll be something like this. So this part, when you revolve, you will get this. So we need only this region. Can you see? From here to here, like, I mean, from 1 to 4, that's the only region, from 4 to 1, nothing else. So let us find the points of intercept. Let's write the equations in y first. In terms of y, what I mean is, because we are revolving around y-axis, even in the last lesson, when we revolved around y-axis, we had to write all the equation in terms of x. In terms of y, that means x is equal to all terms of y at the right side. That is, x square, when I take it to the other side, will be 4 minus y. But you need to remove the square root, so take square root. This would be the answer. So you're writing in terms of y, that means x at one side and equal to all the terms at the other side. So this is it. So this is the given equation. So rearrange and write it like this. Now you need to find the limits. If you have drawn the graph, you can easily understand the y limit. It starts from 1. One limit is already given. What is the other limit? From this graph, you can see y is the intercept. So over here it is 4. Otherwise, you can see at x is equal to 0, what is the y value? X over here is 0, isn't it? So put x is 0, what is the y value? Square it on both the sides, you will get 0 is equal to 4 minus y, y is equal to 4. So the limits will be 1 to 4. Why? Because 1 is given. Y must be greater than 1, but less than or equal to 4. Substitute in the formula. This is the formula. Limits are from 1 to 4. Pi, the function is given over here. This is the function, square root 4 minus y dy. Look, the formula will have, with respect to y dy, that means all this function will be in terms of y. Variable is y. Put it in the calculator and you'll get the answer. So let's just double check. This symbol over here, and then pi. Sorry, again I used alpha, sorry for that. It's pi, open the brackets. It is 4 minus, there is no y symbol, so you use x itself, denoting, but you need to know that you're solving this. Any variable in this calculator, you use x itself, because only this option is for dx, that's it. So, okay, I have made a mistake. That is, I did not use the square root. Now it is 4 minus, this is supposed to be y, close the bracket and square it, and the limits are from 1 to 4. The answer is 4.5. 9 by 2 is 4.5 pi, or 14.1314 unit cube. Again, I've made the mistake. I'm sorry. I will change this error in this PPT and re-upload it. But please note, this is cube. Volume will always be in terms of cube because there are 3 dimensions.